All right, I believe we are live. Good afternoon, everybody. My name is Dirk Rijntjes. I'm the COO of Darwin Recruitment. I'm really looking forward to this event that we're partnering up with Deloitte, talking about their cloud practices and all the programs that they're doing for amazing clients. A little bit about Darwin. Darwin is an international company with several offices in Europe and in the US. We recruit globally for IT talent. We do that on cloud. We do that in digital space, security, and also the data domain. We've been working with Deloitte in the past months to help them out to recruit for their cloud teams. And we have started this event to really put out what Deloitte is all about their cloud engineering teams and how cool projects that they're doing. So I'm really pleased that we have three amazing speakers today, Ivan, Oscar, and Michiel. Just a little bit of clarity around this platform. There are two ways to communicate with us. Say something nice in the right corner. That's just to say something nice. A little bit to the left, you can see ask a question. Please put in that box, ask a question, all questions related to the speaker. Because of the end of the presentation, we have our lovely Sharana coming live on screen to pick out the right questions to ask the speaker. So please make sure that you put your question, ask a question, and not in the white box. So after every presentation, the next presenter will be announced by the right presenter. We hope you look forward to this event. To say this is a recorded event, so if you need to go to grab a glass of water, you can press pause and come back later to it. We will also send you this presentation after at the end, and to make sure that you can look it back. All right, I'm really keen to introduce you to our first speaker, Ivan. Focusing his role is more on IoT and the cloud, and looking forward to your presentation, Ivan. Over to you.
Thank you very much, Dirk. I hope that everyone can hear me. I'm also going to start sharing my screen. I'm getting the too many video sources pop up. I don't know if Dirk, you guys can sort that out. Oh, okay. I think we're good to go now. Okay, so what I wanted to talk to you guys today is an exciting project that we completed not so long ago with Deloitte and the cloud practice at Deloitte for the Dutch lottery. More specifically, we were asked to come in and help them build up their cloud-native sportsbook and casino websites. So the sportsbook being the website where you place your bets, and the casino being a new product which they launched actually last week. So it's now live, and I don't know, you guys can go and check it out as well. What I'm going to talk to you over the next 15-20 minutes, I'm going to introduce myself a bit more. I'm going to give you the project overview, some of the challenges that we encountered along the way, and how we overcome those challenges. So first of all, a bit about myself. I'm a cloud and IoT engineer, originally from Bulgaria, moved to Amsterdam about 3 years ago, and been working at Deloitte for 1.5 of those in the cloud engineering practice. I've got a background in computer science from university, a master's in computer science, and also in my spare time I like to do a bit of music. It's quite cool actually that Deloitte encourages people to do their hobbies as well. So we all enjoy cloud, and we all like to geek out and write code. But we also all have other hobbies as well that we can share with each other and socialize that way. So To give you a bit more of an overview of what the project actually entailed, this is for this one in particular, but also this is a pretty standard project journey that you could expect in Deloitte for most of our stuff. We start with usually a presentation to someone. So in this case, we invited the CTO of the Dutch Lottery to our office, where we showcase some of our work that we've done previously to show our expertise in the field and why they should choose to partner with us. We then usually continue with the discovery phase. So a lot of the times a customer would come to us with an idea or kind of a goal they would like to achieve, but usually they don't have the exact requirements down. So it's up to our expertise to go in and do a deep analysis of their current situation, of their environments, of their places of work, of processes and work, and kind of figure out a way to best nail down the concrete requirements around the solution. We then start with the actual work. We select the appropriate team depending on the requirements. We start the sprint works, or we usually work in an agile way, just because some of these projects take a long time. Requirements may change as new work continues or as new things get discovered. Therefore, it's an important quality to be able to react to these changes and work out the best solution. We then went live with the Total Sportsbook. That actually went to the public while the work was still continuing. This was a few months before the casino, and the main changes here as well was not only the fact that the cloud environment, but also because the Netherlands released some new regulations around online gambling. So these had to all be incorporated as in the new websites. We then continued with some more building for this casino and built the sportsbook. And then we started thinking about the last phase, which was phasing our team out, allowing for the Dutch Lottery to build up their own capability to continue the work forward with us no longer part in it. After all, we come in, we do our job well, and then we move on to the next exciting project. A bit about the challenges that we saw throughout all kind of the important things that made this an interesting, exciting project. As I mentioned, the new legislation was kind of the main driver behind this work. The Dutch government decided that they needed better laws to monitor and make sure that people that gamble online do it in a responsible and safe way. So that all had to be taken into account in such a way that the legislation is upheld, but also that it's still a fun product to use and it's still attractive to the users that have been using it all this time. Scaling and performance was another issue that why we decided to kind of come in and change something up. They had more and more users, and therefore they needed better ways to scale up, especially with the new products coming in, such as their casino website. Another part is the interdependencies with external suppliers. So if you can imagine that the overarching organizations, the Dutch Lottery, they have actually quite a lot of different products. So I've mentioned here too, which is the sportsbook in the casino, but they also have other products on other platforms, all managed by different teams, having different teams working on them. And even within a product like the casino, you have different suppliers that actually make the games that you can play. So the different slot machines and virtual casino games that you can access there. So all of these stakeholders use different teams, worked in different cadences. So all of this was very difficult to manage. And also meant that often it was difficult to know where to get the information from. So documentation was scattered all over the place. You didn't know who really the main stakeholder is for different things. So that was also something that we needed to keep in mind throughout the project. And of course, we're talking about cloud engineering here. So this is why we came in, because really the cloud can help us, gives us the means to overcome a lot of these challenges. So the first point being about the new features. One of the things with the legislation was that we obviously needed a bit of time to develop these features. However, the legislation itself had a kind of a hard cutoff. So we needed really a way to make sure that the features are there and ready to go, so that when the deadline comes in, we can just flick a switch and we know that everything works because everything's been tested. So the cloud really gave us this ability to kind of decouple deployment, development from the releases. So we could develop new features, get them ready for release, and then really release them when we needed to. We talked about scaling and performance, and I imagine there's quite a lot of you here that already have some experience in the cloud, and you know that this is one of its main advantages, is the fact that we can scale really exponentially depending on the needs. So when we talk about higher visitor rates, we can manage that, but then in the quieter periods, we can be more efficient and scale down. The documentation problem as well. So we decided to go for infrastructure as code, basically write everything in code, all of our infrastructure, all of our pipelines, all of our releases. This not only provided a great reference point, but also massively increased our disaster recovery capabilities and being able to quickly change things up. And of course, we had some, the cloud is a constantly developing environment. There's constantly new features that come up that help you kind of tackle the latest changes or the latest challenges that come up on the web and in the IT sphere. And next, I'm going to dive in a little bit more into show you the actual parts that into each one of these challenges. So this whole solution was actually built on Azure. So we used the Azure public cloud to host the solution. And some of the cool features that the Azure public cloud provides is this feature manager. So this is exactly what we talked about earlier, where you can see you create in your application, which was written in .NET, you can create feature flags for different elements. So they're essentially become like control structures where you can select literally a button and you can toggle it on and off and therefore change what the user sees on the screen. This not only allows us to kind of test everything before a certain deadline, but it also allows us to try out different things on different environments. So we can have multiple environments in the cloud where we can select which we can configure each one of them with different features. This makes it not only easy to make sure to test everything beforehand, but it also makes it easier to communicate to different stakeholders at different stages of the process. So as you can imagine, you're sitting in a development team developing something, but at the end of the day, other stakeholders have to approve it, they have to see it before it gets to the users. So the feature flags allow us to really easily do this across different environments, allow them to compare the different views and different ways of presenting the content, which was really handy in the project. We talked about scalability as well and flexibility. The Dutch lottery actually is an incredibly seasonal, it has a pretty big seasonal variance. As you can imagine, Friday night before a football game, you can have millions of hits on the website of people putting bets or seeing how they're changing their bets as the football game progresses and people score goals. They might want to cash out, they might want to add more money or make a different bet. So you see these massive spikes in activity. And then say on a Monday morning when there's not much happening, people are just going on with starting their new work week, you see massive dips in activity. So the Dutch lottery really had a problem with, before they had the cloud migration, they really had a problem with this because they were either running into problems with overclocking and having too much, having servers not manage the load, going down to, or having servers that are just working idle, that are costing money for no return. So the cloud, the way we manage this in the cloud is we use the auto-scaling features. We have to configure them exactly to what the Dutch lottery experienced to kind of get the best effects, which significantly improved their efficiency, so the costs reduced, but they also significantly reduced their error rates, so places where the servers just wouldn't manage the load put on them. We talked about as well infrastructure as code and how that kind of helped us greatly with our documentation and being able to change things up a lot quicker and on the fly. This is an example. What you see on the screen is actually one of our pipelines, and you can see all of our different environments for one of these products. How we use this to document these environments, and we also have the different endpoints for the different checks. So at each stage, we perform checks, and then if those checks pass, we move on to the next stage and until we get to release. And that also significantly improves our reliability. But also what this means is that we can at any point makes it very easy to roll back things. And this makes it easier to do things for disaster recovery and security. The infrastructure, in addition, the infrastructure as code also allows us to make things a lot more auditable. So there is as you heard, the Dutch lottery as a gambling entity is under a lot of scrutiny. There's a lot of audits that get run on its environment. So it was also important to be able to pass those. And of course, the constantly improving features. So for example, in this one, we needed to make sure that the content is actually only accessible from certain geographies. So this was part of the new legislation. So we had to build in securities and firewalls that blocked certain IP addresses from certain countries and allowed others, which was something very easy to do in the Azure cloud environment. Another part, so apart from solving the problem, we're actually creating the product and developing the website. It's also a lot of these are tied around the process itself. So not just building code, but also Deloitte was in charge of thinking about some of the processes that the development teams that the Dutch lottery use, and how can we streamline those, how can we improve those to make them more resilient in the future and allow them to kind of tackle these challenges in an easier way. So we went with a very strict kind of DevOps philosophy, where we kind of go through the cycles of build, test, release, and then operate, monitor, and feed back into the loop. So now I want to show you some of these stages. So of course we had a build pipeline, and I said that before, this is tests in here are very important because, as you can imagine, they have millions. Some of these sometimes they have millions of active users, and we're not talking about. And when the website goes down, it can have quite an adverse effect because if you imagine that, for example, like a couple of days ago, if you don't have access to your Facebook page, it's pretty annoying. But if you don't have access to a page in which you have a wallet, which may have a couple of hundreds or a couple of thousand euros in it, it becomes even more annoying. So you wanted to make sure that we minimize the risks of not being able to access that. And the way we did this is really with rigorous testing throughout every step of the process. So here you can see a small screenshot of our build pipeline, and you can see how many stages our build pipeline has, and how many of those, and pretty much most of those are to do with testing. We test we test the code quality. We run integration tests on the actual website in different environments with different sets of features on them. And we also do manual testing with a testing engineer who actually goes through the story and makes sure rigorously that it does what it's supposed to do, and that it's difficult to break. This is an example of one of our testing suites. So this actually tests the static code quality. So this happens at every commit. The analyzer goes through your code and makes sure that it meets certain requirements. If that doesn't happen, then the the developer is notified, and they have to go back and fix things. So it's a pretty good way to kind of automatically keep track of to make sure that your code quality is good. It also tests things like test coverage, so it makes sure that you've written sufficient unit tests to cover the complete code. We see a similar one here. We can see how many times, throughout the whole process, we keep a track of each stage, how many times it's failed, how many times it's passed. And this kind of allows us to incrementally change our process to make sure that we get better and better and better throughout this as we receive this feedback. And of course, we also do performance testing on the actual finished product as well, but not just as we release through things. Yeah. Something very important as well, I've talked a lot about quality. The way to kind of improve this is not only through better code writing, but also to kind of peer coaching. So it's very it was very good in this project because we kind of separated a couple hours each week with the team to share skills and trade knowledge around different specialist area. So in this project in particular, we had a couple of front-enders, a couple of back-enders, a testing engineer, and a couple of people that deal with the infrastructure in the cloud. And it made it a much more resilient team if the people had not only their specialty, but understood everything else that was going on. So when somebody, for example, was away, you can step in and fix a problem. And this is something that happens pretty commonly through Deloitte projects as well. And it's really good, not only because it produces better work, but it allows you to kind of build up your skills as you go through the different projects. Yeah, and I think this is just around the right time, and pretty much everything that I wanted to share with you today, guys. I hope that you found this interesting, and yeah, welcome any questions. I think I'm going to stop sharing now.
Thanks, Evan. I'm Sharanya. I've been working in Deloitte for the past year. I joined during COVID, and I work mostly in the platform team building AWS infrastructure. Evan, we just have one question from Mariano. They want to know what is the dashboard that you showed during your presentation?
Oh, so that most of those dashboards you see is from Azure DevOps. So we use the Azure public cloud for the infrastructure, and we also used Azure DevOps to kind of manage our DevOps projects process. So you use our build pipelines were there. Some of the testing suites were also hosted there. So most of the dashboards you saw are from there. One of them is the code formatting tools called Codacy, so you can go and check that out. And Lighthouse is the plugin that you saw last, which was around kind of the performance of web pages, how they load, their search engine optimizations, things like that.
Thanks.
Cool. I think there's no more questions. Thank you very much for listening, and I'll pass on the baton to Oscar.
Hi, everyone. My name is Oscar. I will start sharing my screen as well and talk to you about building epic digital platforms. It sounds really cool, right? But before we get into that, a little bit about myself. I'm a senior software engineer at Deloitte. Been with Deloitte for about 12 years, quite a long time. So I've been around for a lot of the journey where engineering was kind of a niche thing for Deloitte, where you had a small group of engineers to what's now our cloud engineering team with 100+ engineers who are involved in some of the most impactful projects at our clients. So it's been a great time to see the journey throughout the company. But like Ivan said, that we do love to code and geek out, but we also have other hobbies as well. Where Ivan's more into music, I'm more of a movie buff. So I go to the theater about once a week. I have one of those unlimited cards, really nice. I like watching series. I play video games. And to sort of balance my couch dwelling hobbies, I also go to the gym quite a lot, and do cycling and hiking to sort of keep my health in check as well. But that's not what you're here for. You're here for my story on building epic digital platform. So we have a big group of engineers within cloud engineering that focus on helping clients in their most complicated business problems with digital assets. And digital assets mean that we bring pre-built components to the project to accelerate value delivery. So we don't have to start from scratch every time and reinvent the wheel, so to say. But let's first start at the beginning. Why do we need these digital platforms in the first place? So what you see happening is that there's quite a large shift that's already been going on for quite a while, from a more traditional setup where companies have an app, a website, and that's how you communicate with them, to a more flexible setup. So instead of hard coupling a product to a channel and having the sort of isolated interaction with the customer, you go much more towards the relationship on a platform level, where you leverage popular digital platforms like Facebook, bol.com, overstappen.nl, you name them. And there's a lot of platforms that we use on a day-to-day basis, and actually also position your products there as part of other customer journeys and aggregation of products to make it more convenient for your customer, and that way you can reach potentially a much larger customer base. The result of that is actually, though, that your IT becomes much more complicated. It's not your own app and backend. You're part of a bigger ecosystem. You have a lot of integrations, and that's where digital platforms become really important. Unfortunately, or fortunately for us, a lot of our clients are not equipped to build these digital platforms by themselves. And not every company out there is inherently an IT company. Not everyone is a Netflix, a Facebook, or an Uber. And what we often see is that clients struggle with building a digital platform or launching new concepts. And that's often because they focus too much on the speed at the beginning and to prove their concept, to make sure that it works. But then when it's time to scale, the foundation is not strong enough to actually support that scale. And promising proof of concepts can fail because of that reason. So you have to build the right thing. You have to actually build something that the customer wants, otherwise no one's going to use it. But you also have to build things the right way. So what's the right way? Well, many modern platforms focus on being componentized and flexible. We see a large shift in sort of the software engineering market from more monolithic, bigger components to smaller components that can run in containers or even serverless. and that offers you a lot of flexibility. Modular design allows modules to develop and evolve independent of others, which makes sure that you're more agile to respond to changes. And of course, scale is a big part of it as well. Ivan talked about it already for the Dutch lottery as well, where you have these peak moments, and you have moments where it's a bit quieter, and being able to handle that scale, but also do it efficiently, that you don't always 100% of the time run at full capacity, because that's quite costly. You have to be scalable. And another important part is being frictionless. And what does frictionless mean? Frictionless means that if your platform is hard to integrate with, you will not survive in the modern landscape. Like I said, everything is an ecosystem nowadays. Everything is interconnected through events, APIs, webhooks. You name all the things that we use to integrate systems. It needs to be as frictionless as possible. Security and compliance is a bit of a no-brainer. We do like making headlines, but we do like making those for the right reasons, and a customer data breach is not one of those reasons. So we do security by design, meaning that we design everything that we do with security in mind from the start, and not like before we go live, oh crap, security. Let's go and do that now. Another key part of what many modern platforms can make or break a modern platform is independence. What we do is something that we call innovation at the edge of the business, which means rather than going into a company's core systems and just yanking out wires and building this beautiful new thing, we actually build something completely isolated from that. And it has a couple of advantages. It's a lot faster, because those core applications for a business are usually quite hard to change, and they're super risky to change. So you're looking at multi-year roadmaps for that. And the second big benefit is that if it does not work, if your proposition does not provide the value that you expected, it's pretty easy to just sink it without having a big impact on the business. And of course, the final one, being agile and fast, is sort of the overall result of all of these things. So one digital asset that cloud engineering brings to clients is the Deloitte Open Data Platform, and that's actually a very strong foundation to build such a digital platform. And it allows us to come into a client and start building propositions for them right away without focusing on all the underlying security compliance stuff, because it's already in the platform. It already supports APIs, events, all that stuff. So we can really accelerate how we bring value to the client, and it allows customers that aren't digital native businesses, and not all companies are engineering companies, to really bring digital propositions to the market fast, because they have this platform to do it with. So how do we actually deliver applications on top of the platform? Well, we use microservices, mainly event-driven communication to do that. It's kind of become the de facto standard for large cloud implementation. I'm not saying that microservices are the cure to everyone's problems, but they do offer certain large benefits, especially at scale. That comes from the fact that they're asynchronous, meaning that every call can happen asynchronously, allowing for much more scale compared to a blocking request where the requester has to wait for the response, and that can be quite limiting, especially if you have a chain of calls that need to happen. And so being able to deal with things in an asynchronous manner is quite powerful. Also, events are a great way to facilitate loose coupling, meaning that components of your applications are not directly dependent on each other and can evolve independently of each other, meaning that it's much easier to add features later on. And for example, if I have an event that an order is placed at an e-commerce store, and multiple components can listen to that event and react accordingly, and you can add new features without changing the whole ordering process, because the ordering process does not need to know what all the other components in the system are doing when an order is placed. So it's a really great way to build a system that's loosely coupled. Another great benefit of microservices in general is, of course, easy scaling. With more historical monolithic development, you build this big box of software, you deploy it on a server, and if you want to scale it, you just deploy copies of the entire box. You cannot easily scale individual features. And of course, with microservices, that kind of changed, where Services become smaller, much more focused on one business goal. So if you have one feature that you need to scale to infinity and beyond, it's easier to do without having to scale all the other parts as well, which is quite efficient. And one unique thing for events, kind of depends on the event technology that you use, of course, is recovery support. So the open data platform mainly uses Apache Kafka. And one of the great things for Apache Kafka is that you're able to durably store events. You have a retention period on Kafka topics, which means that you can replay events over and over again, which can be quite nice. So if you have state in those events, just replaying the stream of events gets you back to the state that you had previously. And that can be quite a good recovery support method compared to more traditional databases that only store the actual current state. If that state gets corrupted and you don't have a good backup, you're not going to have a good day. We don't build only event-driven solutions. So we also support other solution patterns on the open data platform, like big data processing, that kind of stuff that have different challenges, where you have sort of the streaming data, which works very well on Kafka, but you also have like big batch-driven data that is much more suited by products like Apache Spark, for example. And so we offer different solution patterns on the open data platform based on what clients need. Now, technology is all nice, but if you're building a new digital proposition and you're building something new that hasn't been done yet, hopefully, you need a different team of people, right? You don't only need engineers, because we're great at what we do. We build cool stuff, but we do need other capabilities as well. So we work in what we call the freelancers approach on many of our projects, where it's sort of the multidisciplinary implementation of Scrum, where you have people that look more towards the desirability. So am I building something that actually makes sense for a customer? Is it amazing to use? Does it provide value? And you have the feasibility, which is where cloud engineering usually comes in. Can we actually build it, and how do we build it? And like I said before, if you don't build something properly from the start and it comes time to scale, you're not going to have a good time. And what makes the freelancers approach a bit different compared to most, I would say, across most agile teams, is the viability stream, where if you're launching a new business, it's all great if people want to use it, but most of our customers want to make money off of it. And you have to have a good strategy around it. So you develop these three things in parallel with each other, because there needs to be symbiosis between those three components in order for a new digital proposition to be effective in the market. So this is quite a good model to work with, and being on many of these projects, I've had the privileges to work with experts in so many different domains at Deloitte that it's really been a pleasure to do so, and to also understand their world a bit, because I'm an engineer, I love coding, I love cloud and all that stuff, but working with someone who knows everything about financial crime or financial products or different things, and you learn so much that is really, really great to be a part of those projects, and it's really an enriching experience, I would personally say. Now, Ivan already talked about the importance of pushing code to production in a repeatable, secure, and efficient way. We also do that, of course, with the open data platform, where we use DevOps and CI/CD. We actually are already shifting towards more DevSecOps, where not only operations and development is a part, but also security is sort of the third big pillar in that. Like I said, we do take security very seriously. We have a lot of clients in the banking space, for example, where security is such a core thing to what they do that you really want to take that into account from the very beginning. And so our pipeline looks like many other pipelines. You develop your code, you do feature branches, all that fun stuff. You build and deploy it, and the deployment usually checks your code, static code analysis. You do some security scanning on all the libraries that you use. You do some container scanning on the fact, is your container secure, and all that fun stuff. And of course, all your automated tests as well. So you really want to make sure that what you deploy is secure and it works like intended. And that's of course important. One of the final thing for anyone that's ever worked on microservices, architectures, operations, and monitoring is such a key part of your success. And monitoring microservice architecture can be quite challenging. A business request or a process usually goes across several microservices, and if you cannot sort of trace that, see where it fails and how each of these links are performing, then you're really going to have a hell of a hard job keeping that platform healthy, scalable, and working for your customers. So monitoring is really something that we've invested quite heavily in to make sure that we do have all the observability into how our platform is doing that we would ever need. Now, like Ivan also mentioned, we have Terraform to do infrastructure as code, which means that everything that we deploy on the cloud is captured in code, and no one does clicky in the console, because if that person goes on holiday and no one else knows what the clicky he did, then you have a problem. And like Ivan also said, disaster recovery wise, if you have to recover and do everything manual in the console anymore, or again in the console, it's going to take a hell of a long time, and it's going to be quite painful. I wouldn't want to be that guy that under the stress of your entire system is down needs to reconfigure everything manually in the console, that's for sure. And we also use additional tooling like Atlantis to sort of automate deployment of Terraform, 4i principle on that as well, to make sure that we're doing it in a very controlled manner. Now, the final thing before I want to close it off and hope you guys have a lot of great questions is actually open data is initially designed to be cloud agnostic, which means that the core components of the platform are products that are offered by all the major clouds, and so Google Cloud, Azure, and AWS. Which means that if a customer wants to move from one cloud to another or do multi-cloud, the platform does allow for it. However, what we've seen over the past couple of years is that we've been shifting more towards using cloud native services instead, because they accelerate quite heavily, and you don't have all the operational complexity to manage all those components yourself. And also they're getting quite good. I've had several cloud native services that 2 years ago were absolute rubbish, and they're now they're at a place where they're really great, and they accelerate quite dramatically. So what that means is actually that we're starting to see more cloud specific flavors of the platform that we bring to clients as well. It's basically like a toolbox, right? So we have a cloud agnostic toolbox, and we have an AWS toolbox, and so we can bring to clients whatever we need for that project to be successful. That was basically a primer on what we usually do at projects, building great platforms for our clients. So hope you guys have some questions.
Hi, Oscar.
Also stop sharing so you guys can actually see me. There we go.
We just have one question about can we still implement these technologies when the clients are not agile or do not have any legacy applications and they're unable to integrate with all the modern technologies they have?
Yeah, of course. Of course, that's very situational. However, what we've noticed is that, and there's so many integration patterns available that there's usually always a way to integrate. It might not be real time, and sometimes you do data dumps, file system things that are a bit more what I would call legacy. They're not real time, but they still get the job done. So there's usually always a way to integrate. And to come back to the more agile part of the question, of course we work also with companies like big banks, right? That have their own culture and their own way of working, and they're not used to this super high speed, building new concepts. So that's also why the innovation at the edge really works, right? That you build something outside the core business, you can prove that it works, and you start scaling it a little bit to prove that it can scale. And then you sort of start figuring out, okay, how do we bring this thing that works back into the core business in a slow and controlled manner? So there's usually always a way to integrate with them in the end.
Oh, and we have another one finally. The final question is, how would you describe your career possibilities at Deloitte?
We have, of course, a cloud engineering team is mainly a team of engineers. So we have a lot of technical folks at Deloitte. But like I said, we also collaborate with a lot of different people from Deloitte, from legal, tax, strategy, financial crime, you name it. And Deloitte sort of has two career tracks. So you have the regular track in which you can develop yourself towards more of a commercial role, where you go into a client knowing what we can offer and sort of making the link with the problem that they have. So more of a sales role. But we also have the specialist track, where I'm a part of, and we focus more on the content and the technical side. I mean, I love coding, I love technology. It's not like I hate sales. I go into client conversations as well, and I also try to find the link to what they find interesting. But I always do that from a technology perspective, right? It's it's a different sort of way to look in the world, I would say. And we do support technical specialists quite heavily in Deloitte, because, like I said, 12 years ago when I started, we were literally a group of like 15 engineers that had their own department, and I did some small projects for the government here and there. It was really a niche. If you look now, we have over 100 people. Almost every Deloitte event, the projects that we do are showcased as examples of how Deloitte makes an impact at clients. So we're really doing amazing work that 10 years ago we just simply couldn't do. So I would say the career possibilities at Deloitte have never been better for an engineer. And you have the freedom to develop yourself. I don't want to make it into the full 10-minute recruitment talk, of course, but we do offer coaching, training, all that stuff. So we really take good care of our engineers, I would say.
That's it. That's good. Thank you.
Any other questions? No, I think that's it, right?
Mm-hmm.
All right, then I will hand it over to Michiel. Certainly, last but not least.
So thank you, and thanks for announcing me. Thanks for attending this event, of course. I will first start sharing my screen before I continue talking. You should be able to have a visual right now, and I'm going to talk about the fun and challenges which I had, and when I say we, it's me, but most certainly the team that has been working on building a cloud-based client platform from scratch. And we are doing this. We are doing this for a client, and you can see a picture on the background. What you can see over there is actually some steel and a laser which is cutting this steel, and that is what this whole client platform is actually about. But before I continue, let's take a look at what I'm going to tell. I'm going to tell a bit about myself. I'm going to tell a bit about the client, about what the project is about, how did we start, what did we do from a planning point of view, how we started building, and last but not least, why it was fun. During my talk, I will also talk about the challenges which we actually faced. But first, let's start talking about myself. So my name is Michiel. I'm Michiel Tijsterman. I'm 37 years old. I'm married. I live in Overveen, a very small village next to Haarlem, and actually have 3 kids, small monkeys. I would tell them. Talking about hobbies, I know that Ivan has talked about hobbies, so let me talk about my hobbies as well. And one of my main hobbies is building drones. I like building them from scratch. The internet is very easy these days in ordering all kinds of parts, and I like to solder them together in my own hobby room. I have a background in mechanical engineering and electrical engineering, and that's also one of the reasons why I focus here within Deloitte on IoT and Industry 4.0. So I work part-time for Deloitte, 36 hours, 4 days a week, and I'm a manager in the cloud strategy and architecture department. And like I said, I try to focus on IoT and Industry 4.0. And that's also the reason why I ended up at the client, which I've been working for the last, let's say, year. So it's an industrial client. It's actually a group of companies, and they organize themselves very decentralized. So that means that every, let's say, company in this group of companies take care of his own profit and loss, but also takes care of their own IT. And that is very interesting because that means that their IT landscape is very decentralized. And that brings a lot of challenges. And that's why we, together with the client, came up with an idea which is called the Digital Factory, and where we start organizing IT centrally again. So this digital factory consists out of multiple domains, and we are doing projects, smaller and bigger projects for different of these group companies. And the project that we are working on is for a company which processes sheet metal. So we as consumers go to the hardware store and we can buy these big sheets of wood. Well, this particular company processes not the sheets of wood, but sheets of metal, which is very interesting. And what they asked us to do or to help out upon is to take a look at their order process. Because they realized when looking at the competitors that their order process was not very optimal. But before looking into this order process, I would first like to show a bit more about, okay, sheet metal, processing sheet metal, how does it work? And I think this picture says actually quite a lot for you, not right now. So let me explain what you are seeing here. So this is the factory floor. And what you see over here is, you can already see the word, it's a laser. So that's the very first step in their production process. And the laser plays a big role in their production process. What you see on the background over here is the place where these sheets of metal are actually stored. And it's automatically fed into the laser cutting machine. And then the laser cutting machine starts cutting small parts from the sheet. And in order to make it even more practical, this is the sheet, the gray area, what you see right now. And right now, what you see happening is that there are different parts which are being nested on the sheet. So I always try to compare with Tetris. You can turn these parts in the most optimal way so that you can fit a lot of parts onto this sheet, because the more parts you get out of the sheet, the more efficient you actually are. And then the laser actually starts cutting these parts which you see right now from the metal sheet. And what's often then the second step in that process, because if you have a sheet and you cut a part, then it's still a flat part. Well, usually most of the metal parts are not flat at all. So the second step in their production process is called bending. And that is also one of the things that we are currently focusing on. So it's laser cutting and bending. And what this company also does is steps next to that. They can do welding, they can do surface finishing, they can actually do quite a lot. But they asked us to help out on building a client portal, focusing on cutting, laser cutting steel, and doing bending afterwards. So this is then what you see on the screen is then a part which is ordered by a client, and once it's done, it can be shipped, of course. But let's take a look at the order process for now, because how they used to work is, well, I wouldn't want to call it old-fashioned. It's traditional. But if you as a client want to order something at the company, then you would file a request. Either you do it by mail, or you call a salesperson. You send them a technical drawing. So that's usually a 3D drawing about the part you actually want to have manufactured. And then what happens next is that the salesperson or the sales department is going to take a look at the request. So they're going to take a look at the drawing. They're going to take a look at the material which is needed. They are going to do some nesting, and then they're doing all kinds of calculation. Usually, a lot of calculation is being done in Excel. They store it on a shared drive. They do some prints, which they put in a folder. and then the folder goes from the sales department towards the calculator, because the calculator needs to check all kinds of things. And this folder, once the calculator is done, this folder goes to the next stage and the next stage. And well, in the end, a quote is being created, also in Excel, usually transformed manually into PDF, and then the quote is actually sent toward the client, usually by mail. And the lead time of this process, so from first contact towards the sales department to actually delivering the quote, was 5 to 10 working days. Now there is this competitor which they noticed. It's 24/7 Taylor Steel, and this competitor actually had an online portal. This online portal, you could log in with a username and a password, and instead of mailing a technical drawing, you could actually upload the technical drawing. You could select in a drop down which material you want to use and what kind of actions you want to be performed on your part. And then within a few mouse clicks, you can have your quote. So there's a big difference between, let's say, the manual process which our client was adhering to and the way the competitor, and there are more competitors who do it like this, actually function by having an online portal. And that is what our client asked our help for as well, to take a look at that concept and to start building the client portal. So that's the idea, and how we engaged with the client is we started with a design sprint, because looking at the competitor and say, well, they have a portal, I want that as well, it doesn't work like that. Because if you do that, and this particular competitor has been working on the portal for a couple of years, and if you try to copy paste it, then at the moment that you go live, you already lag behind, right? Because this competitor is not standing still. So that is why we say, okay, you have an excellent idea, and we would love to help you with that, but let's start from scratch. Let's think about what is this idea and which customers do you actually want to reach out to, and what do these customers actually want? Because if you don't understand your customer and you just go and copy paste an idea, you won't end up with the product which you actually which the client actually wants. So that is why we started with a design sprint, where we went into a discovery phase, where we did some sketching on paper. We posted a lot of post-its on the wall, and in the end we made some decisions. We even built prototypes, so not by actually already coding into a platform, but we just sketched some prototypes, made some screens, some clickable demo, and we actually validated that with clients. So this design sprint started on day 1, and on day 2, we already started talking towards their end clients. Okay, we are thinking about building a portal. Is this actually which you are currently using? Is this actually something you like using? And if yes, what do you like and what don't you like? And so from scratch of on, we started with an idea. We started making some drawings, and we validated it with the end client. And obviously, once the end client gave some feedback, we followed up upon that. And that is what we continuously did, and that's what the circle is referring to. Once we build something, we test it and we validate it, just to make sure that we're doing the right thing. Can you imagine that you come up with an idea, you start building in your own room, you work on it for a year, and then you go live and realize that the client actually doesn't want your product? So that's something that we wanted not to happen. So at the moment that we executed this design sprint, we needed to come up with a planning as well, of course. So we've been thinking about what would be, keeping in mind that you want to test your product as soon as possible, what would be the most logical way to go live? And we thought that a 3-stage approach would work very well here. So based on the design sprint and based on, well, the assets the client already had, because the idea of the portal, they already started working on it. And they already selected some software for it. And they already had something working. But unfortunately, at the moment that they wanted to go live, the platform itself wasn't supported anymore. So they were dealing with an outdated platform. And to be honest, it looked a bit outdated as well. So what we did is, okay, we have the design sprint. We know what we are going towards to. Let's start with an MVP. And we do that as quick as possible by reusing as much as assets, current assets as possible as well. So we started building in December, and we, together with the client, went live internally, that is, with the MVP in around February. And we use this MVP for internal testing only. So it's a group of companies. So it's very easy to connect to your, let's say, sister company and say like, hey, we internally built this portal. Can you start using it? Because if people use your product, then you get their experience and you can start improving. And that is where we work towards the next phase, which was the minimal marketable product, where we say like, okay, this is something that is already good enough for external clients or external customers, I should say, to start using, but we don't want to open up to the whole world just yet. So we select a few of our, let's say, friendly customers. We give them an account and we invite them to use the portal, and also there again start using their feedback to improve our ID, or the client's ID, I should say. And what we're doing right now is we are working towards the minimum lovable product, obviously based on what we defined and designed during the design sprint. On top of that, the client experience, which we gained, we are now improving our product towards, well, a minimum lovable product. And that is something that we do want to go live with, let's say, nearing the end of the year, and where we will open up towards the world. So this is it from a let's say managerial or planning point of view, but let's make it a bit more technical. I'm not the exact techie, just like Ivan and Oscar are, but let me show you a bit about how we started, because this also ties back to the question. I think it was Ilter who said, yeah, how do you cope with legacy software? Can you actually incorporate that? And that's what we started with as well. So in order to quickly set up something, we decided to use Mendix as technology to build the front end. It was in the Mendix cloud. We used Azure Cloud as well for, let's say, all of the business rules and a bit of backend and orchestration. And we connected to the on-premise environment of the client. And on the on-premise environment, their ERP system was running, but also the legacy calculation software was running there. And this is a key element in this whole portal. Because if I go back a couple of slides, let me just do that, just for your understanding. What you see right here, the 3D part, that is something which is going to be uploaded by the client. But we need software to first make it flat again, because otherwise we don't know how it's going to be nested into the sheet. And then the software needs to do the nesting for us. It's not a manual job. So we need software to reach to the most ideal nesting to make sure that the client gets the best price. And then after the nesting is done, we also need to start calculating, okay, this is, let's say, 2 meters of line, which needs to be laser cutted. How much time does the laser cutting machine need to actually cut all of these parts? Because that, in the end, also determines the price. It's material, but it's obviously also how much time the laser needs to do the job. So we use the legacy software at first. We use the existing connection towards the ERP. To the ERP. We built a new front end, and the back end and all of the orchestration was done by Azure and the components which are listed over here. And that enables us to actually go live quite quickly with the MVP. But we quickly realized that this calculation software was actually not scalable at all. So we were able to use it for the MVP, but we quickly decided for the MLP, we are not going to use it. So that is one of the biggest challenges that we are currently working on, because we need to select a new piece of calculation software. We need to disconnect this tie. In the end, we are going to get rid of the whole virtual machine where this legacy calculation software was running. And we are now working towards this, and it maybe looks a bit confusing. In the end, it's not, at least if you ask me. But here in the middle, we have the Azure application landscape again, And we are adding all kinds of application on top of that. And we are using MuleSoft as, let's say, the glue towards all of these applications. And what you can see is that we added a lot of components already on top of the existing portal. For instance, we connected to company.info again by means of MuleSoft to get company information. So if you create a new account, all kinds of information that you share is validated in the background. What we also did is, at the moment that you as a customer place an order, you're not going to pay the bill right away. We are talking about tens of thousands of euros per order. It's not business or consumers grabbing their credit card and paying right away. No, these people get the bill afterwards, but that's a risk for our client. So what they do at the moment that someone places an order, they make sure that the order value is insured. Well, that's something that you want to automate, and that's something that we built again by using MuleSoft as an integration layer over here. And I think it was something which Oscar told. It's frictionless. So we use a lot of APIs to actually connect. And if we think, let's not do it, or let's improve it, we can disconnect and use another API. So that's how we, in the end, are shaping our platform. And what you see over here as well is that the calculation software, we removed it from the virtual machine. We selected a new provider, and we are now, as we speak, connecting towards this private cloud of the provider and reuse the calculation software. So it's quite interesting, and that's also important. And then let me go to the next slide. So there are a couple of challenges. I think one of the biggest challenges is that it's quite complicated. You've got a lot of stakeholders you need to manage. You've got, for instance, external software suppliers which don't have the same or adhere to the same agile way of working as we are adhering to. So there are a lot of dependencies which you need to manage to make sure that it all comes to one platform, one single platform in the end. So why was this project fun? At least for me, and I hope, well, I'm pretty sure that our developers like it as well. But for me, this is a typical example of a project where you touch upon all of the phases which you can actually touch upon. Because we started with a design sprint, and we've got our creative guys from Deloitte working with us to come shape the ideas, to come shape the future. We immediately started wireframing, so we needed to have UX UI people on the team to help us with the wireframing, but obviously also make a design for our Mendix team to start working upon. So obviously the backend and the Azure business logic needs to be built, and we have our .NET developers for that. We've got our integration specialists which need to be involved in, shaping the MuleSoft integrations. We've got a cybersecurity experts here. We're connecting all kinds of clouds together, but we need to do it secure. And we adhere to the secure by design principle. So we use cybersecurity experts. We also use the marketing department because obviously in the end, once we go live, our portal needs to be found. You need to do some marketing around it. So from beginning to end, we touch upon all of the phases and all of the departments which are necessary to make this portal a success. And that is, for me, that's real fun. The second bullet is about a client which is as dedicated to projects as we are. And that might seem a bit strange, but often clients hire Deloitte to get some work done. But they really point towards Deloitte to get the work done. Well, in the end, you're more successful when you actually collaborate. And that's what we see with this client. They are as dedicated to the project as we are. And that is why it's really fun to work together with them. I think I'm repeating myself here, but the challenge is, while being on the road makes you understand why Agile is so important. I mean, again, you can start working in your room, in your office, you can start building the most crazy ideas, but don't use short iterations. Don't go into your office for a year and then go live, because you will for sure miss something. The world around you is changing, and you need to have this agile way of working in order to anticipate for that. What's also nice to see is that we see the client grow and mature its own digital capabilities. Like I said before, this was more or less the setup of their digital factory. And we teach the client on how to become a digital expert themselves. And at the moment that they start with it, they are struggling with it, but you really see them grow. And that's something different than, well, the typical consultant company. You write your report about how a client should do things differently. You hand over the report and you don't see what happens afterwards. Well, we are on a project, we give them advice, we do the practical implementation, but we take them along in the journey, and you really see them grow, and that's really awesome. I think as a developer, building something from scratch gives you a lot of freedom about, okay, we have a challenge, how are we going to solve it? It's not pre-described. You can think along with the project. And next to that, you can also think about other challenges that the client is facing. And one typical example is, for instance, when you have an order, a client wants to know when it gets delivered, and we give them the option to select a delivery date. But if you really start thinking about what is necessary for a delivery date, then in the end, you end up in the production process, which needs to be predictable. And that's something that the client themselves initially didn't realize, but you need to know how much time it is going to take to get something manufactured. But you also need to know the production planning. So just by looking at the delivery date, you realize that the full process from ordering towards manufacturing to delivery needs to be in place, digitalized, in order to get this delivery date on the screen. And obviously our developers are also thinking along on how to solve the challenges in that. And in the end, working in an international all-star team, it's the company that we are, the client that we are working for is a typical Dutch client, but in the end, the team which is working on this portal is very international. So we've got people working in the Netherlands, we've got people working in Germany, we've got people working in Bulgaria. It's all around the place, and I think this creates a really nice vibe and a really nice environment to work. So I can talk and I can go on for hours about this, but let me stop here. Let me say thank you for listening to my story. I hope it was interesting. I will try to stop sharing and see if there are any questions.
Hi, Michiel. We have a question. The first question is, how do you manage end-to-end communications within all the departments?
Yeah, that's a good one. So unfortunately, specifically during Corona, it's a lot of meetings. So you really need to talk to people, and I think that is one of the challenges which there is, that obviously you create your user stories and you create all kinds of designs, but if you don't talk about it, the design is not going to happen. So it's a lot of talking, and you need to connect to those different departments in an early stage, and you need to take them with you, because in the end, it's let's say our portal, it's our success, but we cannot be successful if the other team doesn't work with you. So it's you need to create an atmosphere where you make them clear that our success is also their success, and if you manage that, then it's a golden team and a golden setup.
Okay. And Alexandra wants to know more about the part-time that you do in Deloitte, more about flexibility that Deloitte is offering.
Yeah, so usually you work 40 hours a week here in the Netherlands, but Deloitte is very flexible in that. So like I said, I work 36 hours a week, and I spread it on 4 days. So that means that I have 1 day off in a week. You can also do it differently. You can work 36 hours a week, and you can, let's say, work 1 week 40 hours, and then the next day you have 1 day off. You can work 32 hours as well. Deloitte is very flexible in that. And in the end, as long as the client is happy and as long as the employees are happy, then Deloitte is happy as well.
Okay. And the next question is, how long did the design sprint period last, and did the clients actually like the outcome of this design sprint?
Yeah. So there are multiple questions there. So how long did it last? In the end, we did it in around 3 weeks, where we went on site towards the client for 2 or 3 days a week. But it was a full-time 3 weeks activity where there was also a little bit of preparation necessary and also a little bit of wrap-up necessary as well. And how did the client like it? In the end, let's start at the beginning. The start was they were hesitant. They were thinking like, what are these guys doing and what do they want from us? Because it's an industrial player. They are really practical. They want to see results right away. And we start with, okay, what's your ID and what's your strategy? And it didn't feel that that was the right process for them. But we kept on saying, please trust the process, because in the end, we go and show you something practical. So at the moment that these wireframes were there, they really realized, like, yes, this is indeed the ID that we had. You translated that into something tangible. And that was the idea from the start, because it's an industrial player, because they're very practical. They like tangible stuff. So the tangible stuff that we delivered was in the form of wireframes, but we also created the customer journey. And in the end, that was, okay, a user comes to your portal, logs into your portal, does this, does that, and in the end gets the product delivered. But we created a poster of around 4 meters, which is now on the wall of, let's say, the higher management of VDL, because they really like the fact that their ID was translated into a user story, which was actually, again, very tangible. So initially they were a bit hesitant, but in the end they were very happy because of the tangible results.
Okay, that's good to know. And the last question is, how do you get your clients to work together towards an MLP instead of just expecting you to take care of everything? Do you have any special approach to this?
Yeah, so for this client, it happened very naturally. And I think that's because it was their ID. And obviously, their ID is something that we translated into, let's say, something tangible. But because of the fact that it was their ID and they continuously identify that their ID is actually something which is being built, that already engages a lot.
Thanks, Michael. I mean, that's it. Like, we have all the questions. I think we have just one more question for Oscar from Vincent. I guess we can get him back on the screen, and yeah.
There's Oscar again.
Indeed. Thanks. Yeah, that's a great question, Vincent. Of course, what I showed was indeed a greenfield scenario, right, where we built something completely new as a digital proposition, just like Michiel did. We built something that wasn't there. Only Michiel had some more challenges integrating with the existing systems that were crucial to the overall chain. With the open data platform, we can also do different scenarios for cloud. You already hinted at lift and shift. When I think at deploying things to cloud that isn't greenfield, you basically have two approaches. And you either lift and shift components to the cloud and modernize and decompose them there as you see fit, where you have like a cloud to data center integration going on, or you internally decompose them first, modernize them, and then push them to the cloud. What I see happening most often is that we tend to lift and shift to the cloud and then decompose, because if you start decomposing internally, you mostly need new tooling, new capabilities that the organization doesn't necessarily have. So hopefully that makes sense a little bit. And we also use the open data platform as a secure landing zone then for if you want to do lift and shift. So open data platform is not just for building new propositions. You can also just lift and shift existing components in there, because at the end of the day, the open data platform is a collection of cloud components with a lot of automation and security and processes around it. And so it can be quite flexible in what it accommodates. But you would be surprised the amount of times that greenfield actually makes more sense, starting from scratch, because we all know that the more legacy systems tend to lack documentation, automated testing, any form of deployment automation, and sometimes even the knowledge, the domain knowledge of how this thing actually works is very lacking because people left over a period of time. So when we go to clients, greenfield or rebuilding from scratch is always on the table as a scenario, and it might not always be the best scenario depending on where a client's at, right? In terms of how coupled and is their application, how large is it, a bunch of other things as well. And when it comes to modernization, we either do in the cloud or on-premise. And we do a couple of things. We usually use the strangler fig pattern to sort of decompose a large application into smaller pieces if that is needed. Like I said, microservices is not the answer to everyone's problems. That's a bit of a thing with the hype around microservices, that everyone thinks that microservices are the only solution to do things, which is really not the case. It's kind of like teenagers and alcohol, right? Everyone talks about it. Everyone thinks that everyone else is doing it, so they say we're doing microservices, which is not really the case. So we look at how to decompose applications if needed. We look at how to step up the everything as code, so infrastructure as code with Terraform or any other language, CI/CD, all the fun stuff to deploy more easily, have automated testing in place and that kind of stuff. And of course, cloud native services. Some of the more traditional client applications might use things that can be replaced by cloud native services, therefore reducing costs and operational complexity as well. And so we don't go to every client with the exact same strategy thinking we know everything. We do take a sort of case-by-case approach to it, but the platform that we have is pretty flexible to deal with different kinds of scenarios. So I hope that answered your question. Of course, you can type something in the chat to let me know. And if there's any other questions still, of course, that's also fine.
I think that's
Nice.
that's it. Back to you, Derek.
All right. Thank you, Sharana. And definitely thank you, Ivan, Oscar, and Michiel for delivering the 3 great presentations. On behalf of Darwin, I would like to thank you. You've put a lot of effort in explaining about your cool cloud programs that you're doing with different kind of approaches. As this is a virtual event, it's quite difficult to hand over some flowers or some champagne, but we do it digitally. So thank you all. Please reach out if you are interested to know more about working at Deloitte, because Deloitte is recruiting. They are growing their teams with multiple disciplines. So hearing from these kind of presentations, if I would be a techie, I would really want to work for Deloitte. So have a great evening. Thank you all for watching and looking forward to see you at our next event. Bye-bye.
Bye, everyone.
Thanks. Bye.